Hi guys, welcome back to shop. Today we're going to start the build on the RM125 Suzuki. Actually, hopefully we'll be done with it today. I'm going to go over a few of the measurements and show you some of the old and the new here. And I'm going to do it a little different this time as far as checking runout. Runout's going to be checked on V-blocks, because if you remember, I couldn't put the holes in the end. So we're going to do that, and I'm a little short on data for this thing, but I think I've got enough to get her done. So let me get you overhead here and I'll show you what we've got. Okay, I've got this. This is, if you've been following this series, this is the crankshaft the gentleman sent me. But it turns out to be a different model. I don't know what model this one is, but it's not the one that we needed. The pin location for the crankshaft is in a different place, so the stroke is different. So this one we couldn't use for that reason. I've got it set in here just for an example, showing you how we're gonna check the run out and correct it. And this one is actually very good. You know, it's really not important how good it is, because we're not going to use it, but about 1/1000 looks like on both sides. So I really like putting it between centers on the lathe. It just works better for me. This, you've got a lot of moving parts here. These, you know, everything moves on you. So you've got to kind of make sure that everything is right. This side over here, I've got a little shim under this side to try to make it the same. So there's a few little issues with this setup, but at the end of the day, it's going to do exactly the same thing, and it's going to provide just as much accuracy as between the centers. Okay, so let's get over here to our pieces that we're going to use. Kind of get this out of the way for now. This one, of course, has got it's plugged, so I can't put my little alignment dowel in there that I usually use on these. So I'll be setting these up with the best I can, just with a square. We'll get it as square as we can, and then we'll put it in the V-blocks and start working on it. I just want to see again, these are the two threaded portions that we repaired. I'm very happy with how it turned out, and I'm not sure, I think I was real lucky. Now, these are the new parts, of course, and what I want to demonstrate here, I'm just going to do it with a caliper. It's easier for you folks to see. Got that zeroed out. Here's the shims from the old one. I'm at about 40.5. Now I'm looking at thousands here. We're just comparing it this time. This one's 39.5. Okay, so those are the old ones, and here are the new ones. And 39.5, and about 38.5. So there's a little bit of difference there, but it shouldn't matter. Our pin, the big thing here is the length, and I'm at 20. I think we've got something kind of raised on that end. Okay, just pretty much 2.2. And our new one, something needs to be pretty close. And it is. It's 2.1975, so almost exactly the same. So those, you know, you don't want one extra long where it's sticking out the sides. Now, Suzuki, like I say, I don't have any information on this as far as straight out of the book. I've got a climber's manual and the data that I had before I took the old one apart. This is all the replacement stuff over here. That's the one I showed you in the V-blocks. So that's not going to be a player. Now, what I did was I checked. Let me get this assembled one out of here so I can kind of show you. I checked here, just like I always do, at the pin, the total width, and the width at about 180 from the pin. Okay, that is all the data that Suzuki gives me. And actually I measured it in millimeters here. So at the pin, I've got 55.67 at the pin and 55.78 180 out. And these measurements here were for this replacement that they sent me. So we're not using that, so those aren't, they're not players. Okay, when I went to the climber manual, it gave me this, 55.9 to 56.1. That's where you need to end up. So you can see that that's a little bit off, actually. You know, if you're a little bit less, it's not as big a player as it is if you're a little bit more. And, you know, 55.9, I've got 55.7, basically. And 56.1 to 55.78. So we're in there. It does not give you a measurement in here. So I've taken that from this spare crank, and I also measured it from the old one, and we're right at the same thing, about 17 thousandths. So I'm assuming that probably 16 to 19 or something like that is about right. But what they're figuring is if you get this dimension right within the data that they give you, or the specs they give you, then this is going to be right. So the only other thing that I can find is this lateral movement up here, where we check that with a dial indicator over here on the side, and that is 0.118 deflection, they call it, on this one. And then you need about 2 thousandths on your runout. And you saw where this one was right at 1. So that's what we'll be checking. We'll get it as close as we can. I just, out of, you know, just kind of gee whiz, I want to check the measurements on the new pin and the holes in the crankshaft. And I'm trying to not get the measurement around these slots here. Okay, so I'm reading 1.7478 or 0.7478. And then on the pins, I was kind of curious what kind of pressure we're going to have here, and I just have gone in here. Now I've already measured this several times to try to make a good determination of what I've got, but I'm just showing you what I've done. And at there I've got 0.745, oops, I moved it, 0.7453. So it appears that we're going to have 2.5 thousandths press fit. So that's gonna be pretty tight. But that's par for the course. You know, 2 to 3 is usually what you end up with on these crankshafts, in my experience. You know, I haven't done all of them, so I don't really know. It's just the ones I've done, that's about where you end up. So the first thing that we're going to do is we're going to lube everything up, and we're going to go press the pin in one side, and then we'll come back and we'll get the rod in. This rod is in good shape. It's was nothing wrong with it. There's no rust or corrosion or anything in there. You can see a little wear from the bearing, but nothing out of the ordinary. That's just the way things are. It's normal wear in my opinion. So what I'm going to try to do is put it together, and as I'm putting it together, I'm going to put my feeler gauge in here to probably at around 18, maybe even 19, and just try to eliminate, you know, because you're always going to have that popping, and it's going to, you know, you get so much pressure and it pops down, so it's bound to go further than you want. So I found that if I do that, generally I can kind of hold that kind of action at bay a little bit. You know, you can always go back in and give it a little more, but I just hate pulling them out. I mean, you can pull them out, and I've done many of them. You don't have to pull them plumb out. You just back it out a little bit and go again. But you just don't want to do that, you know, if you can help it. So let me get all my stuff together here, and we'll get this thing ready. Okay, what we're doing first is we're just going to clean this up best we can, and I'm just going to put a little light oil to help it get started. You know, it's going to push down, of course, you know, that's just the way it works. But that's just part of it. But at least it gives it a little help. So the first thing we're going to do is we're going to go over and we're going to push this even with this surface right here. That's just about how they are. It could be off a little bit on the other one. This one, if you look at it, you've got a little bit of a recess on this side, and it's pretty much flat on this side. It may even be sticking out a little bit. This is a factory one as far as I can tell. So what we'll do is we'll put when we place this over on the press, we'll put the plate right here so it cannot go any further. That's how we'll put the plate. And we got to watch that we don't have it up here, because that could make it push out quite a bit further. So we'll make sure the plate is right against the hole, and that way it'll stop the pin from going too far in. Okay, I just want to show you the placement in the press plates. You know, we've got plenty of room in there, and we've got the pin area right over this plate here, so that it can't go any further. And when I go to right there, it touches that piece that I was showing you on the back side that's elevated. So we'll just back that off to about right there, and it should be everything out of the way. Okay, got the pin located. I've got the crankshaft half located. We're going to put our pusher on top. This is aluminum. And gently come down on it. We got to try to keep it as straight as we can. And make sure that we're properly placed. I think that's home. Pretty tight. Yep. Just right where it needs to be. This was the elevated part right there. So we're definitely under that. So we should have it should be placed properly. It was tight. Okay, let me get all the other components. Okay, then we'll just clean everything up again and get our parts in there. Just get a little lube on everything there. Get our first one in. Alright, that should be all our parts. Okay, I've got everything lubed up, got all my parts in there, and I've been trying to get this as close as I can, and it looks like I'm pretty close there. Certainly not perfect, but it's, you know, that's when you whack it around at the end, trying to get it all lined up. But it's pretty close. And I just kind of lay this in here so that I can tell if it's about the same distance, and it is. I got in there with my little crowbar and just kind of moved that a little bit, and that looks like it's pretty straight. So that's where we're going to start, and I'm going to come down, and it's going to pop. Like I said, these presses get a lot of kinetic energy in them, and you know, they give a little bit, and this one is no exception. So it's when you get close, you've got to do whatever you can to keep from going too far. So I'll just get it started and get her pretty close down to where I think it's not going to pop and give me an issue, and then we'll figure out a way to shim it. So let's see here, see what we can do. Oops, I just saw that kind of go the other way again. You just don't want it starting crooked. Still got a little bit. give it another push. Yeah, it wants to do it every time too. Let me try to get this straightened out. Okay, I just moved my pusher out just a little bit. I think that's going to help keep it straighter. Yeah. Okay, we're getting close to that point. I'm going to pop it out and we're going to take a look at our measurement. Okay, we're at about 5685 millimeters, and our closest to that would be 56.1. So I'm going to go at it with by hand now. It's still going to pop, but maybe I'll have a little more control over it. We're nowhere close to our, I've got a 20 thousandths feeler gauge in here, and we're nowhere close to that yet. So let me give it a little pull here and see if we can get her down a little bit further. Oh, I just about bet you that's too far. Yeah, I think a little bit. Let me see, it'll almost go in there. Let me see if say a 18 will go. I'm gonna let the pressure off. Oh yeah, okay, good. Yeah, that's a tight 18. And I'd measured a 17 coming out of it, I think. So let me pull this back out and let's measure the overall width. Okay, we're getting real close. 56.20. So it probably needs to go just a little bit more. Actually, 56.13 is what I'm getting there. $56.09, $56.08. And turn it around about the 180. And 56.15. So we're real close. Okay guys, I was so close. I was within about probably 8 to 10 thousandths. So what I did was, this was the side that we pressed it flush. So I just set this on the edge of my steel plate here, and with my brass hammer, I whacked it a couple times pretty smartly right here, and that brought the pin up to just about even. And we've got 55.98 on our millimeters, and the book was telling me 55.9 to 56.1. So we're right in there at the pin, and if I go 180, it's 55.98. So we're right on spec, kind of right in the middle of it. And I ended up with a snug 16 thousandths, and I'd measured 17 coming out of it, so that's probably the wear that we had. So this is I'm happy with how it's come together so far. So we'll get it into V blocks and we'll see how far off we are. Okay guys, you're just really not going to believe this. Take a peek here. I've got 3 on my preload here, 3 on my preload here, and I'm zeroed out. It's almost dead on 0 on this side and about 1,000 on this side. I can't believe it myself, and I haven't done anything to it other than set it up in the V blocks. You know, that's pretty darn good for just using a square to line it up. I'm just amazed. Sometimes all the planets align, you know. There's nothing I can do to that, guys. I'd make it worse by far. You see a little deflection here once in a while. It's if I let it slide over to where the pin is that I put in, it drops into there. But this is just amazing. I let it slide over, I think, no problem. Yeah, I'm not going to do anything to that. That's right on. Okay, now we're going to check the small end bearing shake here. I'm just going to hold this to the left and 0 and push it to the right. So we got about 42 or 43 thousandths, I'd say. Yeah, 41, 42. And the limit is 0.118. So that would have to go all the way around and then a little bit. So should be good to go on this. And I can't believe that crankshaft, you know, the runout is acceptable where it is. I mean, I did that with just the square. Sometimes things just happen. I don't know. Anyhow, I'm happy with it. I think it'll serve him well, and it'll be going back to Oklahoma, and hopefully he'll contact me and say that everything is successful and runs and doesn't vibrate or anything like that. Okay guys, there you have it. I think there's 6 videos on this from start to finish, and I put them in a playlist. So if you're interested, you can go back and watch all of them. I'll put a link to the playlist in the description block so that you can do that if you so desire. Again, I saw another gentleman do this, Paul X, and that's where I got the idea from to try this. He did it all in one video, but mine, I think, is I go through and explain pretty much all the steps as we go along. So there is definitely more content to this one, but it was a good project, but a little bit nail biting at time to time, you know, you just don't know whether you're straight or you've done something right. And, you know, at the end of the day, it's, you know, the guy's got to put it together and see if it's going to work. I told him that it was an experiment on my part, so if it blows up, it's not my deal. You know, I'm trying to help him out, and you know, these guys are my buddies I grew up with, riding bikes back in the day, back in the 70s, and you know, they've got something that they're trying to keep running, and it's one of those things that just, you can't find the parts for it. The crankshaft is a 2-year model, 77, 78, I believe, and all the rest of them are different stroke or different ends on them or something. So, you know, they just couldn't find one. And I looked too, and I couldn't find anything. So, you know, what do you do? So we gave it the good old college try here, and I think we got her fixed up. But, you know, if you had to do this and demand payment for it, it would be a lot of money. You know, I probably got 8 to 10 hours in this. So, you know, I would hate to even venture what the amount would be from a machine shop. So you're probably talking $600, $700, $800. But these are my buddies. I'm going to take care of them, and I'm hoping that this will work good for them and will run for a long time. So anyhow, go back and check the playlist out if you want to, and you know, we'll see you next video. Thanks for going along on the ride.